Hello, welcome back to Math Time with Professor Prime, and I'm your host as always, Professor Prime. And today we're going to talk about math and biology. So, when it comes to biology, we're dealing with life at the end of the day. And while that's come up in different ways, in my videos, I wanted to talk about it specifically today because I think biology is cool, both as an academic subject and on that larger level, right? When it comes to math and biology, I think for a lot of people, that idea of like population growth or exponential growth and decay in general come to mind, and it's fair game in the sense that yes, the math is like very clear in that, but it goes so harder than that, and I'm here for it, right? Because like whether we're dealing with population growth models or genetics or cells and what they do, the math is there at every turn. Like math is literally in our DNA, right? It's like it is not only in our DNA, it's you know what that DNA is, how it functions, how it flows, what it leads to. It conveys and has so much information, right? And I think that's fascinating to me, right? Because that DNA, it lets us get our features. It tells us our bodies what to do. It's doing so much even if we can't see it, right? We see the results. And I think it's cool because there's math, like I said, with the DNA, with genetics on a whole, and what we can say about it. And that's ever evolving, right? But not only that, just math as far as cells are concerned. For a lot of people, they'll say that that's, you know, the cell is a unit of life, right? And it's really cool because there's math in how cells are shaped, what they do, how they function, how they flow, their specific purpose, and how that plays into the bigger picture, right? And it's just like it's a rich tapestry of things, and math is at the core of it all. And I think that's cool. And over time, with fields like computational biology, we're getting to see more of that behind the scenes math on a larger scale. And I'd argue more accessible over time, which I hope to continue seeing, right? Because the math is going on one way or another, right? Whether we see it or not. The reason why math exists as an academic subject is so we can better understand what the universe is doing, and how we work, how we function, how we flow. And once we have that understanding, it's like, hey, we can do more things. And with biology, it's an academic field, it gets at the same thing where it's like, hey, life is all around us. And how that functions and how that flows, that's going to happen either way. But we want to be able to say things about it. And over time, we have gotten to do that. And that's just really cool to me. Because, like I said, right, like math is literally in our DNA. And when you think about the life cycle of a human, how we grow, and at what rate we grow, there's just so much math on that. But with biology, there's just like an insane amount of applications with it. Because when I think about biology, it's like, yes, I think about school, I think about some of the things I mentioned, but I also think about things like health, right? I think about things like nutrition. I think about the medical fields, like, and just how all that works, right? Because there's like some nutrition, so some nutrients. There's some nutrients that we need, and when you're looking at our health, right, it's like, oh well, we need X amount of materials. Like we might need this type of vitamin or that type of vitamin. We might need this level of sodium or that level of sodium. Things along those lines, right? To try to bring balance to our system. And when you look at that, and then you look at the types of foods we're having, it's like, well, what nutrients do these foods have, right? Um, and then it's like also like, what about their sugar? What about their fat? What do we need? What are we hoping to avoid? And how does that work? And then you have the idea of exercise, right? And how much we need to do and what that does to our bodies. And with that biology aspect of it, it's like, well, you have the idea of chemistry, you have the idea of physics, and you can't really get around biology without those things. And so you get like increasingly intricate things to look at. And I think that's pretty cool. And as far as medical fields are concerned, it's just there's so much there, right? Because there's math in our bodies, how they function, how they flow, the nutrients that they have. If there's something wrong with the body, there's math in that too. And there's so many things that have been considered over time in medicine and dentistry and just everything else in that realm, right? Because you have these instruments that give you these results and they let you know what's going on in your body. It's like, well, what are we measuring? How are we measuring it? What does it say? What do we need to do? And then there's also the money aspect of it, right? Then insurance on top of that. And there's just so many things to consider that when we're dealing with biology, when we're dealing with things that are connected to it. Then there's math across the board at every level. And I think that's cool. And once more, math is literally in our DNA. And I think that's dope. And I feel like, right, there's so many things you could say about biology. There's so many things that you could say about math. There's so many things that you could say about math and biology. So, with that in mind, please feel free to share. Share your thoughts on biology. Share your thoughts on math. Share something that you thought was cool about biology, where it's like, hey, that's been math the whole time. I would like to hear it. I'll see you in the future.